To further continue into the next lesson, we are going to talk elaborately about the root cause analysis approach. In the electric vehicle diagnostic system, the root cause analysis approach is a systematic methodology used to identify the fundamental cause of a problem or fault rather than just treating symptoms. Okay, so understand the difference between just treating the symptom and to identify the fundamental cause, the root cause, the actual cause of the problem. This method is especially critical in electric vehicles due to complex integration of electrical, electronic, software and thermal systems and the high safety systems. Now, anybody involved in mechanical industry or automobile industry must be aware of various root cause tools like fishbone diagram or 5 methodology or anything. So in this lesson, we are going to talk about the various types of root cause methodologies. Now, what is the root cause analysis? Is a structured problem solving process that aims to determine what happened, why it happened, and how to prevent it from happening again. All right. In the context of the EV diagnostics, RCA, the root cause analysis is used when repeated or intermediate faults are observed. Now, when it no clear diagnostics from DTCs, complex multi-domain issues involving electrical, thermal, software or communication, and after field failure, returns are critical safety incidents. All right. So this is the exact moment where root cause analysis is used for electric vehicles. And when it comes to the key phases of root cause analysis in EV diagnostics, first you define the problem. The clearly document the observed issue from customer or field data and examples. EV shuts down unexpectedly after 20 minutes of driving, or charging fails intermittently with the error P0D3. This is the DTC. Now, when it comes to data collection, collect all the relevant data, including DTCs and freeze frame data. This freeze frame data is extremely important when it comes to root cause analysis, because you have to understand the exact parameters when the exact failure happened. All right. The battery management system logs, event data recorders, environmental data, temperature and humidity, charging system data, EVSC logs, and communication bus logs like CAN and LIN. All right. Now, talking about this symptom reproduction, recreate the failure under controlled conditions if possible. Okay, so the first important step or first usual step, this is not a mandatory step, but usually it is preferred to recreate the failure under controlled conditions if possible, and that helps to determine whether the issue is systematic, intermittent, or thermal related or software development. So at least you can identify what is the vertical which is responsible. Is it a system failure or intermittent failure, or whether it's connected to thermal aspects or software dependent. You can at least find out the at least a vague area on which the symptom is dependent. Now, talking about the system and subsystem analysis, analyze each relevant domain: electrical, insulation, failure, wiring, HV contactors, software, control logic bugs, software versions, thermal, cooling pump failure, battery heating, mechanical connector pin damage, vibration effects. All right. So these are the each relevant domain. These are the various domains you have to take care of. You have to keep an eye on. And using functional decomposition, break down systems into subsystems and analyze interactions. All right. Now coming to the identify potential root causes. Use structured tools to identify and narrow down the potential causes. Now 5 whys technique. Keep asking why until the lowest level root cause is identified. All right. So this is a very important technique, 5 whys technique. And one more important tool is fishbone or Ishikawa diagram, because this particular fishbone technique was developed by a scientist called Ishikawa. And categorize root cause across domains, people, process, machine, material, environment, and software. Now, talking about the FMEA, the failure mode and effects analysis, identify potential failure points and their effects before and after component analysis. All right, so identify the potential failure points and their effects before and after component analysis. Next important step is verification and testing. All right. So when it comes to once a potential root cause is identified, validate through testing. Okay. So the just to replicate that root cause and validate through testing so that the same fault is replicated. Okay, and there are some controlled experiments like A/B testing, software simulations, example BMS fault injection, replacing suspected faulty parts and re-verifying. So these are the various kinds of verification and testing, and use diagnostic tools like oscilloscopes, HV probes, logic analyzers, and CAN sniffers. All right, now talking about the implement corrective actions. Fix the root cause, not just the symptoms. This is extremely important. Many people make a error in this. They fix the symptom, they just what call cover up the symptom, and they usually delude themselves, or they are under the false impression that they have fixed the root cause. Now correct software logic in ECU. Now redesign connector to improve insulation. Redesign connector to improve insulation, or update firmware or calibration. Improve cooling for better thermal management. So these are all the how these are exactly how you fix the root cause, not just what you call correcting the symptom. And more importantly, one important step many people forget while doing a root cause analysis is they don't ensure that recurrence doesn't happen. But this is a very important step. You have to prevent the recurrence. You have to prevent the recurrence and feed the root cause into design for reliability or continuous improvement systems. Now, talking about the update, diagnostic routines, field service manuals, training documentation, vehicle control software, or OTA update strategy. All right. So these are the various the steps or various activities you do or you take to prevent the recurrence. One important thing is training documentation, because once you document a particular failure or the root cause analysis, it will be helpful for the future generations or the future engineers to ensure that that particular documentation or that particular error does not happen. Okay. Now let's see one example. Let's see one example which will give you a clear bird's eye view on the root cause analysis in a EVA fault cause. Now customer comes to the service station and says EV refuses to charge at public stations but charges fine at the home. All right. Now this is the complaint which customer comes with. Now what are the root cause analysis problems? When it comes to root cause, define first you define the clarified issues occurs only on DC fast charging. All right. So it occurs only on DC fast charging. And what is the data? With the help of a DTC, you find out DTC P0D3A, which is pointing towards isolation fault in battery management system. Next, you reproduce in the lab using high humidity DC charger. Again, this is not a mandatory step in my opinion, but some companies to ensure or to get a feel of the real scenario, they can do this or they may do this. Next is you analyze. Found insulation resistant drops only in wet environment, and identify the cause. HV connector boot not sealed properly, moisture ingress. All right. So because of the HV connector, high voltage connector boot not sealed properly, moisture is seeping into the connector. Next is you verify spray mist replicated fault consistently. And to ensure that this is the root cause, you deliberately spray some mist so that this this error is coming in a consistent manner. Okay. Then you zero in that this is the root cause, identify the cause, and then you fix the connector. You redesign connector seal and updated diagnostic threshold. All right. Now with this, many people stop. Actually, this is the biggest error as far as my experience goes. Many people stop here, but the next step is equally important. You have to document or you have to ensure that this does not replicate. Now first is prevent. Supplier part validation updated, OTA BMS update pushed. Now, when it comes to importance of RCA in EVs, high voltage safety, and when it comes to root cause analysis relevance, it prevents recurrence of dangerous failures. Okay, especially in electric vehicles where there are plenty of dangerous aspects. this can be very relevant and very important. And next, when it comes to software defined vehicles, root causes may lie in calibration or firmware logic. When it comes to complex interdependencies, EVs have tightly integrated systems and RCA helps trace cross-functional faults. Okay, this is just a basic example, but in the real life, sometimes the problems can be far more complicated where there is interdependency of the various domains or the various verticals to identify a root cause. Now, talking about the field reliability, it improves quality feedback loop to OEM and Tier 1. And when it comes to warranty cost, it reduces unnecessary parts replacement. All right. So if at all we are able to identify the root cause, then identify the root cause, then this warranty cost can be saved. Now, what are the usual tools and techniques commonly used in electric vehicle RCA? All right. First is CAN log analyzers, bus data analysis. This is one tool. And when it comes to DTC frame phrase viewers, understand fault conditions. Next important tool is 5-eye fishbone diagram FMEA for identifying the root cause. And again, there are some hardware tools like 5-eye fishbone or methodologies, and oscilloscopes and HV probes are hardware tools, electrical signal verification. Now talking about the insulation resistant testers, HV system safety analysis, thermal cameras and hotspot detection, and when it comes to debug ECUs, for example, uh, for tools like JTAG, ETAS, INCA, is a very important calibration tool. And with this tool, you can always use to calibration and control logic verification. All right. So in summary, we are going to identify the purpose, which is to identify and fix the underlying fault cause. When it comes to method, structured, analytical, cross-domain. And when it comes to key steps, first you define, then you collect, then analyze, identify, verify, correct, and prevent. And let me re-emphasize this, even though I already spoke about it. Don't forget this step under any circumstances, because if you forget the step, you most probably will go through all the steps next time if the same error happens. Coming to the benefit, improved reliability, reduced cost, safety assurance. All right, so these are the so I hope all of you got an idea about the root cause analysis used in EVs.